In this lecture, we talk about magnetic field due to a current carrying wire. So say you have a current carrying wire. We have this current I, as you see, is coming out of the wire, and the thumb points in the direction of the current. So this is thumb pointing in the direction of the current. So then the fingers, they curl around, they point in the direction of the magnetic field. So you can see the direction of the magnetic field right here. So the fingers are curling, and this is the direction of the magnetic field. So later on we are going to talk about a current carrying conductor, and for a current carrying conductor, say the current flows in a wire like this as shown in the figure here. So the magnetic field is shown by the green lines. So you can also see this by rotating the figure. Now you can see that these are the lines of the magnetic field which we have drawn here in green, and this is the direction of the current which we have drawn here in red. So later on we are going to talk about Ampere's law, which basically talks about the line integral. So this is going to be your line integral, which will have a dot product. Now most often we will have to evaluate this line integral. Notice there is a loop here. So this loop is generally going to be linked to this green loop. So this green loop of magnetic field. So this loop is nothing but magnetic field, and this is the loop which we are going to talk about later. So in this loop, the angle between ds vector and the magnetic field is 0, as you can see. So for this particular case, you can see that b vector dot ds vector is nothing but b ds cos theta, where theta is 0. So this becomes 1. So this becomes equal to b ds. So this result we are going to use later on. So for a current carrying conductor like this, b vector dot product with ds vector is just b ds. As you can see right here, b and ds have 0 angle between them. So ds is just a small part of this magnetic loop for this particular case.